Okay, math themers, the second category for the second meet is sequences and series. The 3-point question in this category will involve finding a specific term or terms in an arithmetic sequence, inserting a mean or means into an arithmetic sequence, determining the term number within a given arithmetic sequence, or finding the sum of an arithmetic series. No geometric sequences or series will be used. This is for the 3-point question. I've selected a 3 and a 4-point question, but before I do, quick review of notes. A sequence is either going to be arithmetic or geometric. It's arithmetic if it goes up or down by the same amount every time, and that amount that it goes up or down by is called the difference, d, in a formula that you'll see. A geometric one has a common ratio, so 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is, so the ratio is 3. 64 divided by negative 2, divided by negative 2, divided by negative 2. Multiplying by negative 1/2 is the same as dividing by negative 2. So I probably should have phrased it that way as multiplying by negative 1/2, because we're trying to find out how much to multiply by, and that's the common ratio. That'll help you with the geometric series, which again is not supposed to be given as a 3-point question. Here's some formulas that you may have used other forms. I recall in an Algebra 2 class recently that this has been written as A subscript n, and T1 is A subscript 1, so I'm going to use that terminology. Also, we've had it plus D on the outside, n minus 1 on the inside, but it's still the same formula. For a geometric series, you can find the values of specific terms by T subscript n equals T subscript 1 times the common ratio raised to the n minus 1 power. The sum of a finite series of an arithmetic sequence will equal n times the sum of the first term and the nth term, all divided by 2. The sum of a finite geometric series, you take the first term times 1 minus r to the n divided by 1 minus r. Again, r is the common ratio. And we also have a formula if you have where the ratio is, the absolute value of the ratio is less than 1, it's going to be depreciating. So we can find the sum of an infinite geometric series if the ratio, the absolute value of the ratio is less than 1. We can find it by T1 over 1 minus r. A lot of those are not applied to 3 or 4-point questions. In fact, they're not going to be applied to the 2 problems I'm going to do for you. They're from 2017. In the sequence 7, 15, 23, and so on, the nth term is 143. Find n. So I'm going to use A subscript n equals, so the nth term equals the first term plus the common difference. I guess I had to determine that. I had to determine its arithmetic sequence, but I believe it's required to be in order for it to be a 3-point question. I see that it's going up by 8 every time, so I know D is 8, so let me replace that. D is 8. I know the nth term is 143, so that goes here, 143. I know the first term is 7, so I do know quite a bit. I don't know what n is, and that's what we're trying to find. So I'm going to solve this for n. Subtract 7 from both sides and get 136 equals 8 times n minus 1. This often works out nicely that when you divide by 8, it should come out to an integer. So when I divide by 8, let's see, 136 divided by 8. 8 goes into 13 once with 5 left over. 56, yeah, 8 goes into 56 7 times. So 17 equals n minus 1. Since 17 equals n minus 1, if I add 1 to both sides, I'll get n equals 18, and that's what they're asking for. How many terms are there? So when I added 1, I got 18. 18 is the answer. Moving on to the next question. Okay, this is a little trickier because they don't give you the first term, they give you the 10th term is 142. And the 15th term is 187. Find the 25th term. This is the way I tackle this. I'm going to treat the 10th term actually as the first term. That means it's 9 less than what it says here. So the 15th term minus 9 is 6. So I'm going to treat 187 as this is the 6th term. I'm going to treat the 142 as if it's the first term. And in the end, I'm going to find the 25 minus 9. I'm going to find the 16th term. If I do that, it'll be the same as finding the 25th term. I just changed the places of all these. Since it's an arithmetic sequence, I can do that. Okay, so using the same formula as before, but this time there's a different unknown. The 6th term is 187. That equals the first term, which is 142, plus the common difference, which I don't know this time. I don't know it yet, times n minus 1. Well, I do know that if I drop this down to the first term and I drop that down to the 6th term, there's 6 terms in this sequence that I have set up. So that's going to be 6 minus 1. And the only thing I don't know is d. So I'm going to use this to find d. Subtract 142 from both sides and get 45. 45 equals d times 6 minus 1. Well, 6 minus 1 is 5, so I have 5d. If I divide both sides by 5, I'll get d is 9. Now that I know d is 9, I'm going to go back to the original equation but change the values. Probably shouldn't say the original equation. I'm going to try to find the 16th term now that I know the common difference is 9. And the first term is 142. Remember, I changed it from 10 to 1 and 26 to 25 to 16. All right, so the nth term, which I don't know, that's what I'm trying to find out, will equal the first term, which is 142, plus the common difference, which I figured out was 9, times n. Well, from 1 to 16 is 16 numbers, minus 1. Still using that same equation. 16 minus 1 is 15. 15 times 9 is 135. I'm not showing my work, but trust me, 135. You can't use a calculator in this round. 142 plus 135 is 277. That is my answer to the 16th term in my sequence, which is the 25th term in the original sequence. There's more difficult questions if you look at some 5-pointers for practice, but there's a quick review of a typical 3 and 4-pointer. That's it for this video. Have a great meet.